Okay, so as I mentioned, Desmos here is going to be a nice tool to mess with paths if you want to. So suppose I have a point A, and I'll put it at 0, 0. Okay, now I can label that. Right now it labels it as 0, 0. I would rather have it labeled it as A. And then point B, and 1. And again, I'll label it and call it B. This looks awfully crowded here, so I'm going to zoom out a bit. Okay, and what I said is we could do this convex combination of just taking 1 times 1 minus t times the A components, the x and the y, and then t times the b components. And then here in Desmos, I think I can just do it if I just say I might need parentheses, but I don't think so. I think I can say 1 minus, well, maybe 1 minus t times A, and notice it automatically made t go from 0 to 1, and then plus t times b, and looky there, it did a segment from 0 to 1. And now, you know, if you need to figure out the orientation, so did I get the orientation right? Am I going from A to B? Well, you know, one way to do it is just make this smaller, like 0.7. You see, so yeah, I'm going from A to B. That's one way to do it. Let's see, another way to do it is instead of using t here, let's use some other constant like c. So I'm going to introduce a constant c, and I'm going to have it equal 0. But notice what it does is it, when I did that, it made this interval size. So I'm going to have it go from 0 to 1. And I'm not going to give it a step. And then up here, I'm going to change this from a t to a c. And a c. And notice it disappears, but actually if you look closely, and maybe this will help, if I put that on display, you see that one's bigger than this one, the dark part. But now, if I drag this, I can see the point go up there, right? And one thing I can do is, if you hit now play, it actually goes this I'm blanking out on what the heck I call this. Okay, anybody in the audience? Slider. Right? If I do the slider, it actually does that. Now, this is going back and forth. That could be confusing. And so here, I can go to animation properties, and I can say, well, I just want it to go that way. Now, what are some of the other properties? Play once, and this says play indefinitely. Okay, so I've got those. I could even speed it up if I or slow it down if I wanted to. Now I've got it going again. Now it is interesting. There is a way to actually have it trace, you know, the line there, and that is a good question. Oh, I think I remember now. Okay, so you see I have C doing this. Let me put that on pause, and let's see. I think so. Yeah, I'm kind of blanking out on how to get it to trace. I remember now, I think. Okay. So I'll put this back at T. Okay, and I'll have it go from 0 to C. Whoops, not X, C. And there we go. And now notice, now isn't that cool? So it actually is tracing out the path as it goes. And I can grab onto this B, and in this little parameterization trick, this convex combination will do it even if I go like that. Okay, and I'm going to put this back at 1, 1. I almost got it at 1, 1. Okay. So now let's stop that. And you know, as I said, you can do this by doing a segment from 0 to 1, and then a segment from 1 to 1, 1 there. And you don't have to do it with the points. This is really convenient in Desmos to do it with these points. But remember our parameterization. Now I'm going to use x's here instead of t, because t, it likes to do well, yeah, actually I guess I'll keep it as a t. Okay, so we had t comma 0. Okay, and t, notice, see how it had t go between 0 and 1. So t, it really wants to assume it's this parameterization thing. Okay, so there's that one. And then separately, I had 1 and t. And that's not trying to get fancy with this other parameterization, and I just had it go like that. Now, to get fancy with that other parameterization, right, I want t to actually go from 1 to 2, and see, I can see, you know, I can just do it, and I see it's too tall up there. Oh, so what happens if I subtract 1? And there it is. Okay, and then I could get really, really fancy if I wanted to, and do this as a piecewise function. And the way you do piecewise functions is pretty similar to the way we write them, except you do the condition first. And so my condition is 0 less than or equal to t less than or equal to 1, and then I put a colon, and then a comma, and now I'll do 1 less than or equal to t less than or equal to 2, and a colon for what the function is now, and that is the 1 comma t minus 1. Okay, and close that off. And now notice it didn't plot that yet, but now if I go to a 2, you see it's all in black and it does the whole thing. And then once again, I could get fancy, and I'm going to turn this off so it doesn't distract us. I'm going to turn off that one so it doesn't distract me, and I'm going to have C here go up to 2, and again use C here, and go ahead and play that. Oops. And there we go. So I see the orientation of my path, and I see how I would draw my path that way. So Desmos is a really nice tool for checking your path and helping you build a path if that's what you need to do. And it's, I think, relatively intuitive. You know, here I'm just using the points. But here I didn't use the points in that. I just did it as a function of x, x a function of t and y a function of t, and then similarly for the second part here. If I go like that, we can see it all. And there you go. That's some path parameterization with Desmos.